If you don't know what a newbie is, then you are a newbie. You are new to things we're about to guide you through here, so welcome. In this course we're going to learn to be at least dangerous in the use of the Raspberry Pi. The Raspberry Pi is a credit card sized computer. It may be small and cheap, but it's not a toy. You can do some powerful things by learning how to control it, and there's a growing list of projects and achievements on record. The Pi has even gone into space. Control the Pi, and at the same time you'll learn how to operate the very largest computers in the world. 498 of the top 500 systems in the world use the same system. They're all based on what will be shown here. Now, because of the way technology is changing so rapidly, it's highly likely that everything I now say is going to be out of date before it's even uploaded onto the web. Well, perhaps not that quickly, but do try to seek out the very latest information on all of the areas covered here. The Pi is also an example of how rapidly technology is changing. This new edition of videos has been rewritten for and is based entirely on the Raspberry Pi 3 Model B. In the last 4 years since the Pi 1 was introduced, it has gone from a version that ran a single core at 700 MHz to one that now runs 4 cores at 1200 MHz, 1.2 GHz. Its memory size has quadrupled from 256 megabytes to 1 gigabyte, and now has built-in Wi-Fi and Bluetooth radio. Now, you don't need to understand all of this at present, but what it does mean, it's now easier to use and 10 times faster than it was before, without having increased in price. In just 4 years, over 8 million units have been sold, which makes it now Britain's most popular computer, and as a bonus, it's manufactured just up the road by Sony in Bridgend. During these videos, we will use this red arrow to indicate particular items and drop important keywords down as shown, and display an exclamation mark to highlight really important stuff. Very occasionally, there will be data bursts of additional information inserted into the video. I hope they're helpful and not too disturbing. So, where to begin? Lightning is the discharge of millions of volts across the sky. It started life but can be a killer. On a smaller scale, you may have noticed small clicks when you touch metal surfaces, or noticed your hair fizzes up when you wear man-made fibres, like nylon. This is also caused by static electricity and can destroy electronic circuitry. It's why the Pi is supplied in a special protective plastic bag. Before touching the Pi, or any other device, you should earth yourself by touching a bare metal water pipe or central heating pipe. Even then, you should try to avoid touching any connections and hold boards by their edges. Another thing to be careful of is shorting out any terminal connections with a metal object. Let's have a closer look at the Raspberry Pi. The green printed circuit board, PCB, is made of fiberglass and is referred to as the motherboard, as it looks after all of its components like a mother. The first thing to notice is how much space is taken up by connectors. Each is labelled in white on the board. On the right here are a pair of USB connectors. Each connector accepts 2 USB plugs. Below these is an RJ45 network port, labelled Ethernet. The earpiece, headphones or speaker socket is here. A camera may be connected here and an HDMI monitor connects here. HDMI stands for High Definition Media Interface. The power is supplied by this small micro USB connector labelled PWR-in, and another display can be connected here. Finally, there are these 40 pins which make up what is called the GPIO, the General Purpose Input-Output. This allows you to connect other electronic devices, as we will see shortly. On the other side of the board is a micro SD socket for the memory card. If we blank out all of the sockets, it leaves us with the components that do all the work. If we superimpose a heat photograph of a working Pi, the white sections show the hot areas. This shows us that it's this device that does all of the work, or one that gets hot anyway. It is what is known as the SoC, the system on a chip. The main part of this is the 4 processor cores, the brains inside the Pi, that do all of the calculations. This other chip makes the connections to the USB and networking ports. The Wi-Fi and Bluetooth antenna is this device, and this group of devices conditions the power supply. There are two LEDs on this board, a red one that is on when the power is supplied, and a green one that's labelled ACT for activity. On the other side of the board is this memory chip, and a group of components that control the Wi-Fi and Bluetooth radio signals. The board is green, as this is an insulating layer. Under this are the lines that are the tiny copper tracks that make the connections between the devices. These tracks are on both sides of the board, and these dots are tiny holes that take the signal through the board. Just to complicate things even further, there are two more layers of connections sandwiched inside the board, as you can see on this diagram. There's a lot to this little Pi. The Pi can be used on its own, connected to other components using the GPIO, or connected to other boards, or even a touch screen. This one has been included in the dashboard of a car. Nothing happens if you just plug in a Pi. You have to insert a memory card first, and this card has to contain the data that provides it with an operating system. One available option turns your Pi into a PVR, a personal video recorder, which can cost over £150 if you purchase it from an electronics store. Another allows you to run old computer games. The Pi can run Android, which makes it look just like a mobile phone. You can add Windows, but why would you when you have something even better? It's called Linux, and here is Tux, its mascot. It's the software we referred to when we mentioned the control of the 498 applications on the top 500 machines in the world. This chart shows how popular Linux is. The version of Linux ported to the Raspberry Pi is called Raspbian, and that is what we're going to look at next. Linux is a tribute to what can be achieved when the community shares. It began in 1991 when a Finnish student, Linus Torvalds, posted this invitation to join in on an idea he'd been working on as a hobby. The idea was to rewrite an operating system based on Unix that usually ran on machines the size of rooms. Turn these machines on and the streetlights dimmed. He wanted to run it on his PC. It was a massive task, but it all went viral. Today, it's the single most popular operating system by far. You may not recognise the name Linux, but it has been used everywhere, not just large computers, but tablets and watches too. It is the operating system of choice. It also forms the basis. Crucially, it is what is known as FOSS, free and open source software. Open source means that you can actually see, download, modify and run your own copy of the code, and it's free. This is a powerful idea that we will be using on all of the software on this course. There are many flavours or distributions of Linux that various groups publish. The version this course uses is based upon Debian. As it's used to run on the Raspberry Pi, it's called Raspbian. We supply these cards to get you started, but in the spirit of this course, we encourage you to make your own. This is covered in a later video. Connecting up the Pi should be relatively simple, but I've watched in amazement as students attempt to poke any plug into any socket. Consider the Pi as a high-tech shape sorter. Look at the plug, look at the sockets, and the labels on the PCB. Each connector will only go in one way round. The first thing to do is to insert the memory card. The gold fingers go in first and should directly face the PCB. In older devices, this would click into place, but the Pi 3 just appears to grip the card. Next, insert the mouse and keyboard. These go into any two of the 4 USB sockets, which ones don't matter. The RJ45 network plug does click into place, into the Ethernet socket. The small clip on the bottom of the plug has to be squeezed to release it from the socket. Don't just try to pull it out. If you have earphones, headphones or speakers, then these plug in here. This plug is the same type as that used on MP3 players. It's called a 3.5mm jack, and you can forget that fact immediately. Insert the flat HDMI plug into the HDMI socket. It's advisable to ensure that your monitor is already connected, plugged in and turned on before the power is added to the Pi. Finally, the power supply plug should also be familiar, as it's the one used to charge mobile phones. It's advisable to turn on the power to the power supply and then insert the plug into the Pi. The Pi does not have a reset or power button. Inserting the power is all that's needed to start it. If all has gone well, the red LED on the PCB should come on, followed by the green activity light that should flash as the memory card is read. A multicoloured square appears on the monitor, followed by 4 Pi logos. A stream of gobbledygook then flies up the screen as the Pi goes through its boot process. You could also check the yellow light on the RJ45 connector illuminates to prove the connection, and the green LED flashes to show activity on your network. At the end of the boot process, you will either see a text login prompt or a graphical desktop. If you see a text login, enter in lowercase the username Pi and press the enter key. The password challenge appears, so enter the password, again all in lowercase, the default password, which is raspberry, with a P. For security reasons, the password is not shown on the screen. Press enter again. This prompt appears. Type StartX, followed by enter. After a few seconds, the graphical user interface should appear. We are now all at the same place with this Raspberry Pi desktop. You can click on this icon to see what is known as the command line interface, the CLI. This is known as the prompt. Commands are just typed in, followed by the enter or return key. It is a simple but powerful interface that we will explore further in forthcoming videos. The desktop is a graphical user interface, GUI, or GUI as it's pronounced. When you've finished investigating, click on the menu button and click on this option from the drop-down menu. Click on Shutdown from this End Session window and press OK. This surprisingly shuts the Pi down. We used to say wait until the green LED stops flashing before removing the power, but the latest version of software seems to leave this green LED on permanently. So, wait until the screen goes blank and then remove the power. Only then remove the memory card. 2 things to note. Don't just remove the power at any point. Shut the Pi down cleanly as shown here using the shutdown command. Don't remove the memory card until the Pi has shut down. If you do, you may lose your data, or the system may become corrupted and unstable. We've covered a good deal in this video. We introduced the credit card sized Raspberry Pi computer, in particular the latest version Raspberry Pi 3. We saw how care has to be taken when handling any electronic circuitry and took a tour of the board with its connectors. We also saw the location of the important onboard LED indicators. We saw that the Pi can take on any personality. In some form, it can look like a personal digital video recorder or music streamer. It can run Android or Windows, but the preferred option is Raspbian, which is the version of free and open source software operating system Linux that we'll be using in this course. It's Linux that turns this small, cheap device into a system that is used in exactly the same way as much larger and more powerful machines use. Skills learnt on the Pi are transferable to the biggest systems in the world. The Pi is also a gateway to a wealth of free and open source software, and all of the sites that exist to help users run their software. The process of inserting the memory card, connecting and powering up the Pi was followed with a view of the boot process. Once logged in, the 2 views of the Pi were seen: the CLI, the command line interface, and the GUI, the GUI. Finally, the process of cleanly shutting down the Pi, removing the power and then the memory card was covered. This sequence was necessary to help ensure that our data remains valid. Now that we know how to connect, power up and shut down cleanly, we can move on to discover some of the more useful things we can do with the Pi.